Welcome to another Mathnificent Conversation featuring adding and subtracting fractions with unlike denominators. It's your nerdy math bestie Lex. Grab your pencils and let's go. Okay, I'm going to go over some background information, which I like to call mint green tea, before we get started. So I went over some of this in the adding and subtracting fractions with like denominators. In all areas of math, you can only add or subtract terms that are alike, and we call those like terms. When we're talking about fractions, the denominator is what determines if they are like terms or not. Fractions with the same denominator are like terms, meaning they can be added or subtracted. The denominator tells us how many parts the whole is divided into. Therefore, fractions with the same denominator have equal sized parts and can be added or subtracted. If two fractions have different denominators, the least common multiple is the common denominator. So that's some background information. We're going to go over steps to adding unlike denominators, and then we'll get into some examples. Once you've determined the fractions that you're adding or subtracting do not have the same denominator, your first step is to identify the least common multiple for those denominators. Second step is decide which of the fractions need to be multiplied by 1, and 1 is in quotation marks. More about that when we do the example. Once the denominators are the same, add or subtract the numerators and keep the denominator the same. Okay, we want to add 1/2 plus 2/3. The problem with adding 1/2 and 2/3 is, let's take a look at our pieces. This 1 out of 2 is a different size than each of these thirds. So our brain doesn't comprehend adding different size items. It's similar to trying to add apples and oranges. A lot of people understand that. You cannot combine something if they're not the same thing. So when you're thinking about fractions, just understand if the denominators are not the same, the size of the part is not the same. So we cannot combine them together. The only way we can combine them is if they are the same size. To get the same size, we use the least common multiple. So I'm going to do some scratch work. To find the least common multiple means I'm just going to list out the multiples of 2, and I'm going to list out the multiples of 3, and I'm going to pick the smallest one that is common between the two. So 2, 4, 6, 8, 10, 12, and I'll stop there for 2, 3, 6, 9, 12, 15, 18. Now, 2 are common. 6 is common between both, and 12 is common between both. And remember, those keep going. I'm just stopping there. But 6 is the least or smallest common multiple between 2 and 3. So now I know my common denominator is going to be 6. So 1/2 plus 2/3. Remember, you can multiply anything by 1, and I put 1 in quotation, and it stays equivalent because 1 times anything is itself. So if I have 2 and I need to multiply it by something to get 6, I know that something is going to be 3. But I can't just multiply the 2 by 3. I can only multiply by a form of 1. 3 over 3 is the same thing as 1, but it's going to allow me to have the denominator that I want. Now this one is already a 3, so I need to multiply it by 2, but I know I can only multiply by a form of 1. So 2 over 2 is what I'm going to multiply by. So that's going to give me 3 over 6 plus 4 over 6. Now let's see what that looks like. I'm going to take one of my blocks and move it over. Okay, so what does 3 over 6 look like? That means I have something split into 6 equal parts. And I have 3 of them. 1, 2, 3. And you can see how that's equivalent to the 1/2 we started with. Now let's look at 4/6. I have something split into 6 equal parts, and I have 4 of them. See how we have equivalents. 1/2 and 3/6 are the exact same size. 2/3 and 4/6 are the exact same size. But now I can actually add the 3/6 and the 4/6 because they're the same size pieces. And remember, we just add straight across, so this is 7 over 6. And let's take a look at what that looks like. Okay, we have something split into 6 equal pieces. And we start with 3 of them. 1, 2, 3. And now we're going to add 4. 1, 2, 3. We don't have enough. We know that means we need to create another set of 6. So that's something that's split into 6 equal parts. I need to add 1 more. So this is what 7 out of 6 looks like, and it's the same thing as 1 whole and 1 out of 6. Oh. Our next problem is to add 3/8 plus 3/4. Again, notice the sizing of the pieces. Even though I have 3 of both of them, look at how different an 1/8 is than a 1/4 is. A 1/4 is way bigger than an 1/8. So trying to add 3/8 and 3/4 doesn't make any sense because they're not the same size. So now we know we have to make them the same size. We do our scratch work, least common multiple. I'll start with 8. Okay, now let's do 4. And I'll stop there. Again, 2 of them are common, but the least is 8. So I know our common denominator is going to be 8. Now, 3/8 is already an 1/8, so I don't have to worry about it. But 3/4, what do I multiply 4 by to get 8? And it is 2. Remember, we can only multiply something by 1 for it to stay equivalent. So we're going to multiply by 2 over 2 because that's the same thing as 1. So we end up with 3 over 8 plus 6 over 8. Now I have equivalent pieces and my brain can make sense of, I have 3 of something and I'm adding 6 of that same thing to it. So let's look visually at what that looks like. I have something split into 8 equal pieces, which on the left-hand side, that's already done. And we have 3 of them. Okay, and now we have 6/8 over here. Notice how 3/4 and 6/8 creates the exact same sized piece because they are equivalent. So now I have 3 of something and I'm adding 6 of something to it. Again, my brain understands that. So I have 9 of those somethings. The somethings just happen to be eighths. Let's see our visual representation. We already know we're going to need 2 sets because my numerator is bigger than my denominator. So I'm going to go ahead and draw 2 to begin. Okay, we start with 3 of these eighths, and then we add 6 more eighths to it. So our final answer is 1 whole and 1/8. So 9/8 is equivalent to 1 and 1/8. Okay, our next example, 5/6 minus 1/3. Again, notice how the pieces are very different size. The 6 are far smaller than the thirds, or the third is a lot bigger than the 6, however you want to look at it. So let's figure out our least common multiple. I'm going to start with 6, 12, 18, 24, 30, 36. Now stop there, and then we'll go 3, 6, 9, 12, 15, 18. Again, we'll see we have more than one common multiple, but our least common multiple is going to be 6. 5 over 6 is already in 6. I need to multiply 1/3 by a form of 1. 3 times 2 is 6, so my form of 1 is going to be 2 over 2. Remember, this is equivalent to 1. 5 over 6 minus 2 over 6. Okay, let's take a look at what that looks like. Now we have everything is in equal size pieces, and those equal size pieces are 6. So you'll see we didn't have to change the 5 over 6. We still have 6 equal size pieces, and we have 5 of them. But our thirds, now we have 2 of those 6 equal pieces. But now we are subtracting. So remember, from my 5, 6, I'm going to subtract 2 of the 6, and that's going to leave me with, remember, subtract straight across, 3 over 6. Let's look at what that looks like. One, 2, 3 out of 6. Remember, we don't leave anything not simplified. 3 is already prime. 6 is 2 times 3. 3 over 3 simplifies to 1, and we're left with 1/2. And if you look at our final picture, you'll see that 3, 6, 3 is exactly half of 6, which is why that simplifies down to 1 out of 2.